Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT ONE, the consultancy that specializes in supporting digital transformation of operations and businesses. Our guest today is Ed Hemphill, head of Edge Ecosystems at Pelion. And Pelion is a division of ARM that provides secure global cellular connectivity and feature-rich management for any IoT device or edge application. In this talk, we discuss the value of integrating IoT connectivity with device management, and we also explored the uses of edge applications and best practices for keeping edge deployments secure and reliable. If you found these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iotone.com. Finally, if you have a business challenge you would like to discuss how IoT ONE can support, you're welcome to email me directly at erik.walenza@iotone.com. Thank you.
Ed, thank you for joining us today.
Hey, appreciate it, Eric. Thank you.
So Ed, before we get into Pelion and the topic of Edge, I'm really interested in understanding your background, where you came from. I know you joined Edge as part of an acquisition of a company that you co-founded, but maybe we can even start earlier. When did you first touch on the IoT topic?
Yeah, sure. So, I had previously kind of been involved in communications industry for a long time. So, years before I'd been in the U.S. Army and did, radio and tactical communications and special operations. And then I later was at a startup that did video conferencing. And so during that time, we kind of got very interested, me and a business partner got very interested in how do we automate things in a conference room? How do we automate things in a building? And that was kind of the genesis for what became Wigwag. And so Wigwag was really focused on building a platform where you could interconnect very easily different devices. So you could say, I want this sensor to drive this action with these devices in this room or in this building. And it took us a long time to build a platform that could really begin to do these things. And as I'm sure a lot of people in the industry that are listening to this podcast know, it turned out that IoT and everything involved in it to do that was just massively more complicated than we thought it would be. But in the end, we developed a pretty rich, powerful platform that ended up using it we ended up pivoting kind of towards commercial, and it ended up using in gas stations and sort of an HVAC control and things of that nature. And then that literally led us to partnering with ARM and where we are today inside of Pelion.
Yeah, got it. And I'm curious about the U.S. Army experience. I was just interviewing somebody who was with the Israeli Army and then left and started up a company also in edge computing. They were building chips for machine vision, for specialized chips. The Israeli Army is a bit famous for kind of spinning off startups, right? So having a very tech orientation. Is there a similar kind of anomaly or analogy to that in the U.S. Army?
Well, probably not so much as in the Israeli Army. I just think that the technology, and of course, everybody in Israel is in the military and has to be in the military at some point. There's so many people, and then Israel is such a technology-focused country in so much of their industry that I think you see more of it. Of course, a lot of it around security and stuff like that. But certainly, I think anybody that gets experience in the military starts to see the military tends to test out a lot of new technologies that later make it into the mainstream. So like if you take mesh networking, the U.S. Army was doing that stuff, about a decade and a half before anybody else was with tanks, for instance. There's a lot of ideas and a lot of challenges that you have in the military in terms of robustness of communications, the fact that it just has to work, that you have like really nasty environments in terms of RF, right, and things like that to make things work. So, I think people that live in that environment maybe aren't as daunted by the challenges that IoT kind of, has in it. And of course, IoT has a lot of the same challenges, right? You got distance problems. You've got buildings that you got to get RF through concrete, through steel. there's a lot of parallels, I think, between IoT and that stuff.
Makes sense. I mean, the military is an early adopter of a lot of these technologies. So great. So then Wigwag was acquired by ARM. You were director of Pelion Edge. What's the status of Pelion today? Is it a business unit of ARM? Is it a subsidiary?
Pelion is a business unit of ARM. Yeah, so Pelion is a business unit of ARM that operates under the name Pelion for today. So Pelion is essentially a separate operating company, and Pelion is really the genesis of a decade and a half of effort by ARM to create a very modern software infrastructure for IoT. And they started a long time ago, long before Wigwag was a part of it. Numerous acquisitions that built Pelion essentially, along with a lot of in-house innovation from ARM itself. And so what Pelion is at the core of it is essentially a cloud service that allows you to connect both what I call device to cloud devices. So those would be things like little tiny microcontroller devices that typically would be able to dial up and talk directly to a cloud service because they have some kind of radio or capability to talk to the internet. And then also there's a whole edge and gateway component that I've been happy to be a part of the innovation there, and that's Pelion Edge. And so that's a big piece of what Pelion is in terms of device management. But don't forget that also, some viewers may not know, Pelion also encompasses a huge connectivity piece. And the connectivity piece is basically a global MNO that allows you to get connectivity for devices all over the world. So essentially you can slap a Pelion SIM in and you can get IoT grade connectivity for a device that works in a vast majority of the world.
Gotcha. Okay. So the portfolio you would say is the platform, and then the SIM, is this a physical hardware? Is this an eSIM?
Well, yes. So they support both physical SIMs, eSIMs, and they have some other innovations as well. There's a management portal for the connectivity piece. I'm not the expert, of course, in that side of the house, but we're integrating all these services together. And so that's really why you see some sort of big names out there that are beginning to work with us. And that may be where people are beginning to see our brand out there, is because they're able to go and they can get a contract set with us that allows them to get both global connectivity over through most of the globe, along with a device management IoT solution. This just prevents a lot of work that would otherwise need to be done. I mean, you can imagine if you were setting up a global IoT product and you had to go out and you had to do contracts all over the world with various carriers, some in Europe, some in Africa, some in Asia, some in North America. And then you're building a product on top of that. It would be quite exhausting. So it's a way for our customers to accelerate all that getting done at the same time.
Gotcha. On your homepage, there's 4 kind of aspects of the value proposition: IoT connectivity, connected device platform, IoT device management, and edge application management. I think the IoT connectivity is fairly clear or easy to understand. So global connectivity with one SIM. But if you can walk us through the others, and what does this really mean, and how does one solution differentiate from another solution? So if we look at the connected device platform, what are the key functionalities here?
Yeah, so the connected device platform is kind of talking about the ability for you to have this portal capability that lets you manage anything that's in our IoT connectivity service, and also lets you manage various updates that would be available to a device that's using our connectivity service, or the management of the SIM that's associated with that connectivity service. And also there's a corresponding portal that goes to the device management service as well that allows you to do firmware updates and other things like that. So what they're speaking to there is sort of the gluing together of both connectivity and device management. And then to speak to the other two, traditional device management from the Pelion perspective has been traditional kind of application for this would be, I'm going out and I'm creating 10,000, 100,000 little widgets. And these little widgets, whatever they do, they're going to need connectivity to a cloud service that's going to be there for many, many years, right? And you need to be able to run that cloud service and guarantee that cloud service is going to be up for extremely long period of time and have extremely robust over-the-air updates for that service. And so that's what traditional IoT device management has meant for Pelion. And then, of course, edge applications management, the piece that we're bringing, which is sort of the newer piece that I specifically am more involved with is Pelion Edge. Edge applications management is really saying, okay, I'm managing gateways and these edge boxes now, but now I want to be able to dynamically orchestrate applications on them, right? So I want to be able to deploy this application now and maybe a minute later, a different application, or maybe a year later, a different application. And I want to be able to manage that using the same kind of DevOps techniques that you would use if you were managing a traditional cloud service. And so that's what we're offering in the edge management or the edge applications management piece there. Hopefully that gives people a differentiation of the 4 different things that you see there on the page.
Yeah, got it. And let's go a little bit deeper into edge. This has been really quite a hot topic lately. So a lot of interest in. I think there's some group of people that are a little bit still confused about what do we mean when we say edge? Because they say, well, we've been using on-premise for whatever, 50 years. And then the big shift was to the cloud. So everybody was talking about the cloud for 10 years. Now we're talking about the edge. How do you differentiate edge from on-premise?
So if you hear the Pelion marketing and general product discussions, you'll hear the term on-premise and edge. And when we say on-premise in our product line, we're typically talking about an entire cloud installation. So you could take our whole cloud service for device management, right? And you could run it in, say, an isolated factory where you might not have connectivity anywhere else. Like, for instance, if you've worked with Foxconn or any other large manufacturer, that they, in these factories, they basically don't allow any internet in there, and you're not going to probably even be able to use your phone because they want a secure environment for their customers, right? Understood. So if they're going to be using an IoT product, they're probably going to need an entire on-premise solution, an actual cloud, if you will, in a box or in a set of boxes, set of small servers that's running in that factory that allows them to run an infrastructure that's essentially confined to that building or that set of buildings or that campus. So that's what we mean by kind of on-premise in our product line. But edge, we're really talking about a much lighter weight solution that can go in any x86 or ARM Cortex-A class box. And that would be a set of software that's really going to let you just deploy applications downline at a specific gateway. These days, I'm trying to kind of move away from the term gateway also, just as an aside, because I feel like that makes people think it has to be gatewaying 2 protocols together. And I think we're beyond that now in IoT. What we're really talking about is being able to just get an application out towards where the customer or the need is, right? So for instance, if I want to do local processing of video, and I want to be able to count the number of people that are going through a hallway, or let's go back to our factory example since we were there. In the security of the factory, I want to be able to know how many factory workers have entered the building. And then at the end of the day, I want to make sure most of those factory workers left, and I want to be notified if they didn't. I can't move all that video up to the cloud constantly and expect to have a decent performance and a near real-time performance on noticing people and counting them and doing all the image processing necessary to do that. So instead, we put that logic down, that AI model basically down at the edge, right? And so now we're able to deploy, and that's an application. So now we're able to deploy that application down at the edge. It runs locally, and then it only needs to move the pertinent data back up to the cloud, which would be 100 people in, 100 people out, that sort of thing. On-premise is really more about running an entire solution somewhere, whereas edge is about getting the application where it needs to be.
Gotcha. Yeah, it does feel, we were doing a tagging exercise recently, and we're looking at gateways and edge computers as categories, but there's a lot of blurred lines now in this. There's different configurations that have different types of connectivity and intelligence and so forth, but it's hard to find a proper gateway, for an industrial solution that doesn't have some degree of intelligence.
That's right. And what you're seeing too, Eric, is more and more of these gateways from traditional manufacturers. We don't need to name them, but we all know all these various manufacturers that make gateway boxes. You're seeing more and more of those come out with pretty capable chipsets, right? Whether that's like NVIDIA Jetson parts, which can do a tremendous amount of AI processing, all the way to lighter weight kind of specific ML chips that can still do a decent amount of stuff, if you're just trying to do lightweight processing and distill it down and put it to the cloud. So yeah, it's a whole spectrum of stuff, right? Like, is caching technology an edge application? Sure. Is digital signage an edge application? Yes, it is. Is a kiosk an edge application? Yes. In my view, edge covers just a huge amount of applications. Could it be point of sale software? It could. And I think that really, one thing that's great for Pelion is that widens our potential footprint, right? The kinds of opportunities that we're interested in and helping customers solve.
Yeah, well, maybe we can get into that side of the business now. So on the one hand, this is a very horizontal solution that could be deployed in many different situations. But as with any business, there's probably specific industries and types of companies that you work with. Where's the bulk of your business today?
Yeah, so we've seen a lot of traction so far, at least in the edge application space around industrial and building, smart building. And so that's been a lot of our focus. We're also quite focused on utilities as well. But let me talk about the industrial and smart building space for just a bit. So I'm sure you're familiar with these terms, Eric. I don't know if all the viewers would be, but we have these terms OT versus IT. So operational technology versus, information technology. And what's been happening in a lot of these spaces where you have the merging of kind of traditional old school PLCs or microcontrollers, sort of that hardware box that nobody knew much about, that's set in the back, that controlled the HVAC or controlled the security on the doors and the ventilation in the factory. What's happened is slowly those things have become connected to the internet. And it's taken a long time compared to a lot of the rest of the world, the rest of other things that have been connected to the internet, mostly because those things are mission critical and you just can't mess them up, right, without having big problems. And as they get connected to the internet, the IT folks in an organization start getting a little concerned about those things because a lot of times they haven't been upgraded in a long time. They don't know anything about them. The firmware is kind of a black box that no one understands. So the people that are in this industry, these industries that build the boxes that control these mission critical things in buildings or in factories, they understand this and they totally get this problem. And so what they're wanting to do, and they are doing, is they're beginning to create solutions that both provide a solution to the operational technology folks, but also meet the needs of a modern IT shop in a large company, right? And so that's what we're helping a lot of businesses out with, whether that be folks like some of our publicly known partners, such as Honeywell or such as Johnson Controls, but also companies that are actually running factories or companies that are doing specific vertical solutions for different industries as well. So examples of that might be stuff that's going on in factories, people that want to create security systems to monitor people or activities in a building and so forth. Anyway, it's that IT and OT merging together and this massive change that's happening is sort of the big theme I see out there right now.
Yeah, and I mean, maybe a little bit of a divergence, but we've been hearing a lot about cybersecurity issues lately. I mean, we had the biggest pipeline in America hacked. We had then just last week the largest pig farm, a Brazilian company, but with huge operations in America hacked. And I believe in both cases, it was a bit more the back-end IT system rather than the kind of operational infrastructure that was infiltrated, but still that it shut down operations because they weren't exactly sure how is this going to impact. What is the role of Edge? Is there a role? And then if so, what is it in enabling you to, let's assume you are going to be hacked, right? Viruses are going to infiltrate you. How can you still continue operations?
So one of the things that I think is important to note in any kind of critical infrastructure that you're putting in is, you've got to have security in depth, right? And I'm sure, we all talk about this all the time and that term's become very common. But for Pelion, what it means is everything that we've done in our stack has a security aspect to it and is built to be highly secure, right? So as an example, we have a program called Pelion Ready for Pelion Edge. And Pelion Ready is basically where we work with gateway manufacturers to have Pelion Edge pre-installed and really ready for use by an end customer. But what we're doing in that program is we make sure that manufacturers individually key every gateway that goes off the line. And every gateway that does go off the line, having this unique key set, even if that gateway is compromised, it really cannot allow a hacker to easily access the rest of the system, whether that be our cloud services or get access to another neighboring gateway or so forth. It's very important to have a security model, or multiple security models really, that are throughout your entire stack, that are they're basically creating stopgap measures every time something might happen. Because the truth of the matter is, if you run a global pipeline or you run a global utility, you will get hacked. you will get hacked and one of your devices will get compromised. The idea that it won't is just ridiculous. But it's an issue of if it does, what is it going to do to my overall infrastructure? And so that's where a tremendous amount of the thinking in the Pelion platform has gone into is, sure, something can be grabbed, something can be compromised somehow, right? Whether somebody gets physical access to the box, even solders a chip onto it to do something, it can be done. But if that does happen, what is it going to do to my overall strategy and my overall infrastructure that I'm running? Is it going to kill me? Does it create a massive risk? And so we put a lot of stopgap measures in there to prevent that from happening. So like, for instance, we can blacklist the single gateway. We could blacklist an entire manufacturer if we had to. If we knew that a line had been compromised at a manufacturer, we could do something about that. So anyway, these are all ways to mitigate risk. But I think in all this stuff, I think what companies got to ask themselves as they worry about these things is, look, something bad will happen from a security perspective, but how am I mitigating my risk and what are my stopgaps that are going to prevent it from a small fire to becoming a forest fire? That's our approach to those problems.
Yeah, well, and then you had the reverse flow. So I think there you were talking about kind of protecting the endpoint and making sure somebody can't move from the endpoint to the mothership. But then there's also, I think in these situations, somebody hacks some procurement system or some back office system. And then the concern is that this could impact, operations. So, I suppose there either combination of edge computing or on-premise server would allow potentially operations to continue despite the fact. Yeah.
Well, I think you're right. I mean, I think that's why our on-premise offerings kind of continue to get a tremendous amount of popularity. And of course, we offer the edge services as a part of the on-premise offerings too. So you can run Pelion Edge services on gateways with the on-prem. Obviously with an on-prem solution, if you want an even more robust solution, then, the clear answer is to essentially run isolated instances or very lightly connected instances, right, between buildings or between major locations. And I do think that's one of the reasons that facilities like major manufacturers, for instance, they're going to run pretty isolated systems because they realize there's a risk stuff could get somebody, especially an inside employee or something, could allow access. And by keeping systems segmented, it prevents a lot of problems. So, talking about going back to the military and stuff, of course, these are common practices across all militaries in the world. But for highly secure systems, you're going to run isolated systems, right? If they're highly secure, they're basically isolated because it's the only way to really create the ultimate stopgap between stuff getting out.
So coming back to the topic of industrial and building cases, I know you've recently signed an agreement, or Pelion has, with Johnson Controls. Can you just give us a bit of the rationale behind this agreement and how do you see these partnerships helping to move the business forward?
I can't speak at a super in-depth level with the Johnson Controls relationship, but I will say that across all of our deals, especially with an organization like Johnson Controls, it kind of comes back to what we were talking about just earlier. There's a great need to modernize industrial and building infrastructure and the IT and OT technologies associated with that stuff. And so all of these companies, what they're wanting to go to is a much more dynamic model where they're able to deploy applications at will very quickly. So let me kind of give you a case study, if you will, around this. I don't know if I'd call it that, but it's just sort of a general template of what we're seeing. Traditionally, these companies created a pretty rich software stack. A lot of times it was just this big monolithic stack that would go on a box, or perhaps it had some kind of modularity to it. But in any case, that stack was installed at the factory and it was shipped out to a customer site and maybe through a distributor. Heck, it might have even sat in distribution for a year before it got there. And it may never be upgraded again, Eric. It might have sat there for a decade and never have been upgraded. That means there is stuff out there, as I'm sure we all know, that's running Linux 2.x kernels today, right? It's all over the place. And the bottom line is a lot of that stuff won't get upgraded. And I think that's a lot of the things that freak IT shops out, right? So what they want to do, the common thing we're seeing with folks like Johnson Controls and other folks is they want to go to an infrastructure where they're going to be able to push out applications dynamically, which is a totally different game. So they want to be able to take a box, they want to be able to send that box to a customer, that box might not have a lot on it to begin with. It might just have the basic connectivity and some core applications. And then they want to be able to completely change the type of software they're delivering to that customer over time. So they may say, well, this customer needed these features from my building automation services, but now they actually want some whole new service that I offer that has to do with energy management, or that has to do with access control to the building. And that's an entirely new application, but now I can provide it dynamically. And so that's a general theme that they need. The second big theme that folks like Johnson Controls need is sort of a bigger picture, which is they want to be able to work with a provider such as Pelion that can provide them the connectivity piece, first of all, that they need throughout the world so that they can make a product and basically ship that product almost anywhere. And they want to be able to do that with a cloud service that they can choose whether they want to run it on premise on their own hardware or their own infrastructure, or they can take that software and they can run it on AWS. They can take that same software, they can run it on Azure. They can take that same software, they could run it on Google or whoever else. And that provides them with a level of assurance and flexibility that they wouldn't get out of a solution, perhaps, if they were stuck on a specific cloud provider, or if it was a solution that just didn't offer the ability to switch providers or to run it on their own metal if they want to. So I think those two big things, right? The ability to deploy applications dynamically and kind of remodel your business. And then secondly, being able to have the flexibility to go with on-premise or with your own, any kind of cloud provider you want, provides a tremendous amount of flexibility. The cloud thing where I can choose which my cloud provider I can use, and I'm just continuing to use Pelion APIs, is super important now that you are looking at things like the changes that have happened in Europe with security, for instance, right? New laws that have come out of China that are changing where data has to be stored. And then a lot of other countries are following suit with those same things. So what this is creating is these big global corporations that are creating products. They realize they have to have solutions that are going to be able to accommodate all these changing dynamics in the law. And of course, with us, what they can do is they can run an on-premise solution in China. They can run an on-premise solution in Geneva or in Europe somewhere if they need to. So.
And this is a very common challenge right now. So, from both sides, from the operational side, but also it's a big opportunity for companies that have been selling devices in and are trying to look at how they can provide value-added services on top of, maybe hardware that they've been selling for decades. And this makes it much, much easier, right? Like you said, you can evolve the software over time. You can add functionality over time. And can you get into the business model a bit? So I assume this is some kind of subscription model, but what does this look like from a business standpoint?
We have a couple different ways we sell our software solutions. So number one, all of our edge software, the software that actually runs on the gateway, or what's called Pelion Client, which basically is a library and a very flexible set of software that you can run on all kinds of different microcontrollers or different microcontroller OSs like FreeRTOS or QNX or whatever. That software and the Pelion Edge suite, which runs on Linux, all of that's open source. So customers don't pay for that. But obviously we make our revenue based on a software subscription model. Now, customers can choose to use our public cloud services, which have a well-published pricing model, which is essentially based on the amount of devices that are connected to our public cloud. Customers can also choose to go with a private cloud option where we essentially run our infrastructure for them, but it's their own cloud services, their own dedicated resources, their own performance characteristics that they need. And we can run that on whatever cloud infrastructure they want to use. And then we also license our entire cloud itself. And that's the on-premise solution that we talk about. And that would be where we might license, for instance, a Pelion cloud to run inside of a factory on the customer's own bare metal or on their own Kubernetes or OpenStack architecture. So our on-premise solution can run on OpenStack, on Kubernetes. And we have quite a few tools that allow you to quickly spin up that on-premise solution. It can flex from one single 1RU server to an entire rack or more, if that's what you need. So anyway, the business model is basically those two things. It's either licensing or it's a subscription model with the amount of devices. And then on the connectivity side, we basically have plans that allow you to add the amount of devices that you need and the type of connectivity and data rates that you want for connectivity for devices.
Gotcha. And on the connectivity side, I know this is not your core focus, but just what does roaming look? Is there a roaming? Is there kind of like there's a parent or a core, a home country and then roaming, or is it just country by country where what rate applies?
My understanding is you would be able to do that based on the kind of contract you sign with us, but there's no real roaming per se because it's a global MNO. So what you're able to do is, you have a SIM, it uses a specific APN, and pretty much wherever you go, it's going to work, right? And our portal will allow you to make certain types of changes and provide certain capabilities once devices are out in the field. And in fact, you can even migrate SIMs from one type of service to the next. So those are some of the capabilities that are there. And what you're going to see from Pelion over the next year on that general line of thought is you're going to see us merge more and more of our connectivity management services with the device management services. So today, they're a little bit separate services. So I kind of go to one portal for the connectivity management versus another portal for device management. But where we're headed is a much more integrated offering. And that's going to add a lot of power because it means that I'll be able to say, change this device to this type of service and also upgrade its firmware, right? And do that across a fleet of devices at the same time. And so those are some of the things you'll see from us soon.
Gotcha. Well, why don't we then get into the tech stack a little bit? And it's always, at least for me, a little bit more challenging with a platform than it is with hardware. Okay, we build this and here are the specs and so forth. And of course, that you have, I'm sure, a big development team of very, very intelligent people working hard at this. But can you help to, in kind of as simple language as possible, help us understand what are the underlying technologies and what are the different variables where you might see a significant improvement in the coming years? So what are the big goals?
So I'm going to focus, where my expertise lies, which is on the edge class devices. But let me discuss that. So first off, let's just start kind of at the edge, because like you said, sometimes it's easier just to kind of start with the hardware. So Pelion Edge itself really comfortably needs about 512 megs of RAM, more comfortably a gig of RAM on an edge class device, meaning it's at least a 32-bit ARM CPU. And typically our customers run on a 64-bit ARM CPU or it's an x86 CPU. 1 gig of RAM is usually nice just because it gives you enough headroom to deploy as many applications as you want. The way the tech stack works on the edge is basically it's a set of Linux processes, some of which do different things. If you kind of look at our offering, it's comprised of 3 core categories of capabilities at the edge. One of them is sort of used by everybody, and that's the systems management piece. And so our systems management components allow you to get a lot of the things you would expect with a traditional systems management system, such as remote logs, remote control of system D or other processes, configuration of network parameters. For instance, like if I want to set up one Ethernet port to do this, one Ethernet port to do that. And then, of course, we have our firmware update services. So that allows customers to do everything from just patch a single file to go all the way to upgrading an entire partition in one fell swoop. So it's a pluggable system, so they can do any of that. And so that's the systems management component. And then we have a device management piece at the edge. And what that is essentially a set of software that allows you to easily publish device information. So for instance, let's say that I have an existing stack. Most of our customers, right, they're coming to us with already having existing software and stacks, right, that run on some gateway. So let's say I have an existing stack that knows how to talk to some Modbus stuff that I manufacture or that I work with. That Modbus stack, if they want to get that Modbus data to the cloud, they simply need to make that process now published to our local software bus that runs as a part of Pelion Edge. And so they just make a simple post to that bus, and then that bus will automatically move that data up to the cloud whenever the cloud's connected, and it'll make that data available to other processes on the box. So for instance, the strategy here is I can keep my traditional legacy software without really modifying it much. And all I have to do is just get its data to the software bus. And then I can also build a modern application that listens to that software bus and does a whole new set of things, right? And so that's the purpose of the device management piece, essentially. It's to interconnect processes with device management data and send that data to our device management server, which normalizes everything in lightweight M2M. And I'll talk about that in a second. And then our other big capability, of course, is the edge application orchestration, right? And so our edge application orchestration is based on Kubernetes. Kubernetes APIs essentially work very similar as they would in a normal Kubernetes installation. And then we've added a number of really important capabilities to our services at the edge for application orchestration. And probably one of the most powerful of those, not to get into all of them, is a tunneling capability that allows you to form a WebSocket to our cloud, and then that WebSocket lets you talk directly to a container, right? So this is really cool. For instance, if I have an existing container that holds a legacy application, in the past, the way my technician might have interacted with that application is they may have talked directly to this gateway on the LAN, sitting right there on the LAN with that gateway, right? And instead now they would be able to run that same application, but they just need to talk through a WebSocket to our cloud, and then it can let them talk directly to that application. So it allows our customers to rapidly build remote management capabilities without having to modify their legacy stuff much. So that's a big win for customers that are trying to rapidly get stuff to the edge. Take a breath there. That's our software stack, sort of in a nutshell at the edge. I guess I'll just briefly talk about the cloud services that go with it. So in terms of data management and device management, we have something called the device directory. So it's a very robust system that scales extremely well. And the device directory allows you to see all of your devices in one directory, and it allows you to see all the data associated with every one of those devices. So what we do on the gateway side of the house, on the edge side of the house is, for instance, if I want to modify which logs I can see on a gateway, I simply use this device directory to look up the gateway, and I can just modify one or two data points in lightweight M2M, and I'm able to reconfigure the way the log manager works on that one gateway. Here's what's cool. If I want to do that now across a dozen or 100 gateways, the API calls are essentially the same. And by the way, if I also want to do something similar, but it's now a microcontroller device, and I also need to update that information on the microcontroller device, by the way, those APIs are very similar. So in the cloud, what we've done for customers is we've created a very normalized look at the world, even if you've got things that are very diverse out there in terms of your devices. Everything from a tiny microcontroller device running our tiniest stack all the way to maybe a very rich gateway that has Pelion Edge running on it. So that's the way configuration management's done. That's the way device data is received from different devices. And that's the way also that non-IP data that's being pushed through our gateway is published as well. So in the same device directory, you can look at your Modbus information that might be coming from those devices that might be connected to that gateway that talks Modbus. Right next to it, you might also see the amount of RAM that's available on that gateway right now and the amount of RAM that's being used. So anyway, that provides some color, I hope, to the way that stack piece works. And then, of course, there's the cloud services are there, obviously, to do application orchestration. Our log management, Eric, is stored in Elasticsearch. So it scales very well, and you can use a lot of different tools to go through the logs like Grafana and so forth. Anyway, that provides some color, I hope.
Yeah, no, that's great. And it makes sense that this is your focus right now. I think this is touching on a lot of the pain points related to the complexity of dealing with legacy infrastructure, which is not going away for the next 20 years. What then is in the future? I understand that for the near future, you're going to continue to focus on integration. If you look over, I don't know, let's say 3 to 5 years, what would you see as the big development efforts?
Well, without getting too much into our non-public roadmap, what I can say is a lot of our customers would like to see, number one, we're already doing this. Number one, we're already working with a number of different manufacturers with this program called Pelion Ready. And Pelion Ready for Edge means, traditionally it took customers a little bit of time to get the software stack Pelion Edge, that's a variety of processes that run on Linux. You got to install it, you got to set it up. It was a bit of a hassle. What we're trying to get to for customers is we want them to just be able to, just like you can order a laptop that runs Windows, and the moment it arrives at your house, you can crack it open and you can pretty much be up and playing with Microsoft Word in a second, right? It's never going to be quite like that for IoT, let's be honest. But where we're trying to go is that for customers, it's going to be a heck of a lot easier to get a certain kind of application running at a certain location, right? So what our vision is around Pelion Ready in terms of the hardware partners is we want our customers to be able to say, you know what, I just spun up a new location. Let's say that I'm a massive sandwich chain in the United States, and I have 10,000 plus stores. And I just decided to spin up a new, I have a franchisee that just spun up, 20 new stores in the last week. I should be able to drop ship from a manufacturer gateways to each one of those stores without ever touching them myself. It should be simple enough that my store operator can just plug in that box, and then those should light up on the network, on my cloud service, on my dashboard, and I should be able to rapidly deploy the applications I need running down at each one of those stores without my IT staff ever having to touch, get involved, deal with anything different than they normally would, right? Now, to a DevOps guy that is used to dealing with modern cloud infrastructure, using Kubernetes or a similar system and deploying containers, they get that. They're like, well, sure, that's the way our pipeline works. As soon as we want it over there, we just decide to upgrade that one YAML file and bam, we have completely upgraded all those containers to the latest version, right? And we need to roll it back. We can do it the same way. But in hardware and in gateways and in IoT, it's totally the opposite of that. It's still very old school. So that's where we're going with Pelion Ready program is we want to make it where customers can get those gateways out the door and deploy them and put those edge applications physically somewhere with it modeling very similar paradigms as they have in modern cloud DevOps. And where we see that going over the next year or two is, I think the natural progression of that is going to be like, okay, what other software can I put on those boxes through different partners? How can I easily get software put onto those boxes? So you could see how once I can quickly put a box somewhere and have it connected to my account on Pelion and be able to manage that box really without ever having to do anything more than just use my mouse and keyboard. Now you see how you also want to be able to choose from world-class software providers where you can deploy certain kinds of applications directly to those boxes. And so that's what we're now looking at very heavily over in Pelion is how do we enable those capabilities for our customers?
Today, I assume, I don't know what it looks like with Pelion, but in many cases with deployment, system integration is going to be 30% of the cost or some significant proportion. So getting that down will be immediately a very large savings.
And the other thing we find too is like that it's not just the cost, which I think most of the time they don't even know the cost because they're not really measuring it very well. But it's just so much time. And so then they look at how much time it's going to take them to IoT enable something or to edge application enable something, if you will. And then they look at their actual business case for what they're trying to do. And they're just like, oh, this doesn't even make sense. By the time we get this done, we will have missed the opportunity that we're trying to solve, right? So this is all about speed. At the end of the day, what all of the stuff that we're doing and with the Pelion Ready program and the stuff that we're working on with Pelion Edge, it's about speeding up the ability for customers to get apps out there and solve problems quickly. So yeah, we got to make it easier on them because easier is faster.
Yeah, got it. Maybe we take a step back and if you can just maybe wrap up by walking us through given the tech stack as it is today, what does a deployment look like for a typical case?
Yeah, so a typical deployment, the way it looks today is customers, first of all, need to get the Pelion Edge software onto their gateways. And that's either happening with the help of one of the manufacturers or it's happening at their IT shop. And so they will have spec'd out and ordered enough gateways that they're going to be able to distribute those where they need them to be. And the way they flash each one of them, there's a set of tooling that makes sure that each gateway is uniquely identified and has its own unique certificate. And once those are out in the field, let's just use the example of building automation. So if they're at each building or a couple are at each building, then they immediately come up in the cloud for that customer's account because when they flashed each one of them, they were associated with that customer's account, the tooling they were using. And so they're going to see those light up as soon as they're plugged in and powered on and talking to our cloud services. And then they essentially can use all of our management features. So they can immediately start deploying applications for them. If they go run kubectl get nodes, for instance, as an example, for you Kubernetes folks, they're going to see a list of nodes. Those nodes are their gateways. And they're going to be able to deploy an application to each node just like they would if it was a node in the cloud. And then in terms of systems management, there's a variety of tools and examples that they could follow quickly to be able to upgrade files, to be able to upgrade packages, sideload packages, for instance. Pelion Edge runs on Ubuntu, it runs on Red Hat, it runs on Ubuntu Core, it runs on Yocto. We have customers that are using it on all kinds of flavors of Linux. And by the way, I wanted to give another example. I think that's pretty good around this typical use case stuff. We have another customer who's essentially in the automotive industry, and this customer, for instance, is using a SoC that both has a Linux side and it also has a microcontroller side. And so those same firmware update APIs can be used to upgrade anything that's attached to the Linux OS. And so in their case, they're using those firmware update APIs to also upgrade the more hard real-time side of that SoC, which has to do with the actual vehicle-specific capabilities, right? And so what they're able to get out of that is even while Linux is booting, that other microcontroller side of the house is running and doing what it needs to, yet they can use Linux to manage and upgrade that critical firmware that's more on the hard real-time side. So I don't want people to think about the firmware update APIs as just things to, manage packages in Linux. They're actually much more flexible, and customers are using them for, much more richer, more mission-critical tasks as well. You could use those same firmware update APIs as an example to upgrade the firmware on a PLC that's downline from the gateway. And we have customers doing that. And the way they would be talking to all these gateways is they have a cloud in our public Pelion instance, or they may be using an on-premise solution. But that's the way it kind of typically looks.
Quite straightforward. And it sounds like this is a good step forward for the market in terms of simplicity.
As straightforward as IoT can be.
Exactly. Yeah. Ed, I think we covered a good bit of range here today. Anything that we missed or anything else that you wanted to bring up?
No, I think we did a good job of covering a lot of the bases, and I appreciate your time, Eric.
Thanks for tuning into another edition of the IoT Spotlight podcast. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iotone.com. Finally, if you have an IoT research, strategy, or training initiative that you would like to discuss, you can email me directly at erik.wallenza@iotone.com. Thank you.